Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Now, a question that may come up is, what is the value of installing Ubuntu Server onto your Raspberry Pi? So the Raspberry Pi OS that you install is a full Debian distribution of Linux, and therefore it will do almost everything that you need Linux to do. So the question then becomes, why would you install Ubuntu if Raspberry Pi OS most likely can perform the way you need it to perform? The reason that I would argue you should install Ubuntu Server operating system, if you want to, is basically for standardization. So if you're thinking about using a Raspberry Pi in a production environment, that means you have a lot of Linux machines in your environment. Some of your Linux machines are going to be servers, some of your Linux machines are going to be IoT devices such as a Raspberry Pi, some of your Linux machines may be virtual machines that are up in the cloud. One of the big problems for support professionals, frankly, is standardization. Although most distributions do exactly the same thing as all the other distributions of Linux, the thing is that they use different syntax many times, and they use different commands in order to accomplish the same task. So if you're going to be using something like CentOS versus something like Ubuntu, there are literally different commands that you use in order to get the same end results. So this can be a really major problem as a support professional, because basically you sit down and you start tippy-tap typing out on a Linux machine, and there's that whole question of like, do you know Linux? And that's the problem, right? You can know Linux without being an expert of the particular distribution that you're sitting down and dealing with. So if you're using multiple distributions of Linux with in your environment to do basically the same kind of crap, this can become a real problem for your support professionals, because basically they sit down and at this machine they've got to deal with Raspberry Pi OS, and at this machine they've got to deal with CentOS, and with this machine they've got to deal with Ubuntu Server like 14.01 from a number of years ago, right? So every time they sit down, instead of simply being able to sit down, pull up the command line and tippy-tap type out the commands that they know will work, they've got to sit down, tippy-type out a command. It fails. Oh, why did it fail? Do a Google search. Oh, this is this distribution of this. So for this distribution, blah, blah, blah. So they go back, right? So on and so forth. So the big argument that I would have for using Ubuntu on your Raspberry Pi, frankly, I mean, it's not a sexy argument. It's not sexy. It's not cool. It's not like, wow. The real thing is standardization. Basically, if you or your support professionals are used to using Ubuntu, then having Ubuntu used across the board will just make it easier when your people or when you sit down to actually do configurations or maintenance with your Raspberry Pi in the future. So the fact that Ubuntu will work on the Raspberry Pi, I've seen no downsides with Ubuntu working on the Raspberry Pi. It's kind of one of those things, okay, you're going to put this in the field, you're already using Ubuntu in a number of different situations, why not simply use it on your Raspberry Pi too? So there's no major warnings for today's class. There's just a couple of things to think about. Do realize that the distribution of Ubuntu that you're using for your Raspberry Pi is the ARM distribution of Ubuntu. Now, I have to say 99.9% of the scenarios you're going to run into, basically the Ubuntu that runs on your Raspberry Pi is going to work identical to the Ubuntu that's going to work on a normal x86 processor. But do realize that this is a different processor. Ubuntu did have to get ported to this processor, and there may be some quirks with some software. Let me be clear. There may be some quirks possibly that you might run into. Probably not if you're using the standard server software that you use on an Ubuntu box. Again, if you're using the Apache stack or the LAMP stack on the Raspberry Pi, that's going to work fine. If you use Samba on the Raspberry Pi, that's going to work fine. OpenVPN on the Raspberry Pi, that should work fine. So again, 99% of all the things that you'll use your Raspberry Pi Ubuntu little box for should work fine. There might might be some of like the proprietary software out there. There might be some specialized software out there that will not run on the ARM processor. So all I'm going to say is basically test, test, test before you put it into a production environment. In your little demonstration lab, in your lab environment, I would argue this should work fine for you. I really don't think you're going to have any problems using Ubuntu on your Raspberry Pi. But again, if you did go into the production world, maybe you have some kind of special storage software or something like that. I don't know. Just realize you might run into an issue. So test the hell out of it before you do put it into a production environment. The other thing that I will warn you is I will show you how to install Ubuntu, and it's very simple. Basically, the way you install Ubuntu is the same way you install the Raspberry Pi OS. TLDR, too long did not read. Just basically you can install it from the same software, the same app that you use to install the Raspberry Pi OS. But I will warn you that there are two versions of Ubuntu. At least when you get the selection box. So when you use the Raspberry Pi installer, you can select Ubuntu, and then there's multiple different versions. There's a 32-bit version of the server, a 64-bit version of the server, but then you're going to see IoT core versions. Be very careful with that. Basically, the two versions that you can easily install of Ubuntu on your Raspberry Pi are the server version and the IoT core. The server version is the standard command line server version that you should be completely familiar with if you're worried about Ubuntu. So if you've used Ubuntu in the past, basically using the server version, whether it's 32-bit or 64-bit, will be the same that you're used to. The IoT core version of Ubuntu, though, you do have to be careful with. That might be the right option for you. Maybe. But make sure. Basically what that is it's a very, very stripped down version of Ubuntu with the idea of being that you're going to be putting this into the field for IoT devices. So one of the big issues with IoT devices is that they can be security vulnerabilities for your network, right? So if you have a full-fledged computer, right, that can have a full lamp stack, that has, storage and all that kind of thing, one of the big problems you can have is if somebody can root one of your Raspberry Pis. So you have like a little Raspberry Pi, and let's say it's just controlling your HVAC system, your air conditioning system. If some hacker is able to root that box, then what they can do is they can use all of the power of the Raspberry Pi to then start attacking your internal network. So that can be a very big problem. Do remember, every feature that a server or a device gives you is also a vulnerability. So FTP is a feature, and it's a vulnerability, right? HTTP is a feature, and it's a vulnerability. Samba is a feature, and it's a vulnerability. So the more features, the more functionality you have on your box, also the more vulnerabilities you have on your box. So the IoT core distribution of Ubuntu basically tries to strip out everything that you don't need. It gives you an incredibly clean installation of Ubuntu, and then the idea is that you then build on top of that for whatever it is that you need in your specific environment. If you're expecting server and you install IoT core, you might start ripping out your hair when a lot of things that you're expecting to be there, a lot of like the kind of default installations that simply are not there. So that's one thing to keep in mind. Today, we are going to be installing the server. Again, when you're playing around, when you're doing demonstrations in a lab environment, I would argue go for the server. The server runs amazingly well on the Raspberry Pi. I don't think you're going to have any big issues with it. But then when you're thinking about going into the production environment, then that's the time to start thinking, okay, should I really have a full-fledged server OS on here, or is the IoT core a better solution? And then at that point, go do research on the IoT core, make sure it does everything you need it to do, so on and so forth. So anyways, with that, let's go over to the demonstration computer. We will create the little micro SD card for a Raspberry Pi with the Ubuntu server installation on it. Then we'll go over to the computer and I will show you how it all works. So here we are at my demonstration computer. Again, I'm using a MacBook Pro, but this little app that you use will be the same whether you're using Ubuntu, whether you're using Windows, or whether you're using Mac. So you're going to have the option for the operating system over here on the left-hand side. So if you click on this, again, you got the Raspberry Pi OS. That's what we installed before. Other Raspberry Pi OSs, and then we're going to come down here to Ubuntu. And again, it's important to understand this is just one of the default options that's given to you with the Raspberry Pi Imager software. So you don't have to add any image files or anything like that. From there, basically I can click on this, and again, we've got 4 options here. So we have, right now, we have Ubuntu 20.04 LTS. It's a 32-bit server. So this is the server one. Then we have the 64-bit server. So these are the first 2 options. Then we come down Ubuntu Core 18. So this is Core for IoT. And basically with this, we've got the 32-bit, and we also have the 64-bit. Again, I would highly recommend that you stay with just the 32-bit server when you're initially doing your play around and your tests. Going past that really depends on your environment. So 64-bit may actually give you a lot of performance improvement depending on what you're doing, but do realize some apps may not be compatible with 64-bit, so you may run into issues there. And then again, as I talked about with IoT Core is kind of its own little world. So unless you want to deal with IoT Core, just deal with a 32-bit server. So basically just going to click on that. Again, for the SD card, we click on whatever SD card we have here. Let me click on this. Oops. There we go. Don't know why it's doing that. And then we're going to click on the write. When it asks me to write, it's then going to ask me for my password. After I've put in my password, it is now writing to the micro SD card. And depending on how big your micro SD card, speeds, and so forth, it takes a couple of minutes. Okay, so now we have imaged the Ubuntu operating system to our micro SD card. So we can now take out the micro SD card, put it into our Raspberry Pi, and boot the Raspberry Pi up. So now I've slotted the micro SD card into the Raspberry Pi. I'm now plugging the Raspberry Pi in, and we can see the initial beginning boot process here. And again, nothing too complicated. If everything seems a little small, one of the issues here is I can't change the font size for the initial boot up process. So you're just going to have to deal with it. But again, basically what you're just going to see here is just the normal boot up process for Ubuntu. Now, one of the things that I will warn you that is a little bit weird here is that there is an auto update procedure that happens as soon as you log in for the first time. So basically what it does is it starts trying to download and install some certain updates. Why that matters is while it's installing those updates, you can't install other things. So you may run into problems. So like when I first did this, the first thing I wanted to do was install Apache 2. So I was like, oh, okay, great. I've got this little Ubuntu server. I'm going to install Apache 2. I went to install Apache 2 and I started getting a whole bunch of errors because the installation process was already being used. So when we do go to log in, the login username is Ubuntu, Ubuntu, and the password is also going to be Ubuntu, Ubuntu, and then you start getting this crap. So the first thing that's going to happen then is it's going to ask you to change the password. So as soon as you log in for the first time, it doesn't want you to have the default password. So here, you're then going to put in the old password, which is Ubuntu, Ubuntu. Then it's going to ask for a new password. I'm going to use a super secret, 1 2 3 4 5 6 7 8 9. If you try to do 1 2 3 4 5 6, it's too simple. It's too simple for Ubuntu. But 1 2 3 4 5 6 7 8 9 is just fine. 1 2 3 4 5 6 7 8 9. And now we have a new password. So basically, at this point, you can see that I have the normal command prompt down there, Ubuntu add Ubuntu, and we can go in and we can start doing things. So we can do like sudo top. So we want to take a look at top. This shows us the processes and the things that are going on. We get out of that. Again, you can do ls-l. Whatever. The problem you are going to have, though, if you do sudo apt-get install, let's say Apache 2, you may run into an issue where, again, the installation process is already being used. So that's when I click on this. Right now, I get could not get lock, blah, blah, blah. Be aware that removing lock, blah, blah, blah. Unable to acquire the DPKG front end lock. Now, it's very important here when you see this, you do not need to delete the lock. So if you go and you do a Google search on what's going on here, there's a whole bunch of forums about deleting the locks. The thing is since this is the first time you've installed Ubuntu, basically the first time you're running Ubuntu, what's happening right now is it's just doing the initial update process. So I would highly recommend you do not go in and modify the locks or anything like that. That may cause you issues in the future. It's much better to wait 5 or 10 minutes for the installation process to finish, and then you should be able to do whatever you want to do. If we click on it again, we still have the issue. So let me come back in about 5 minutes, and I just want to show you that this on itself will clear after a couple of minutes, and then you'll be able to install Apache or whatever other packages you want to install. So I've waited about 3 minutes to see if the installation process has stopped yet, to see if we can install Apache 2, just to give you a real-time idea about how long this takes. So let's try to install Apache 2 again. And it's still locked. Still locked. So, okay, let me come back in about another 5 minutes to see if this is finished. Okie dokie. So I'm back after another 5 minutes. So we're about 8 minutes since installation. Let me try to install Apache 2 now, see how this works. Oh, it's still locked. Oh, this may actually take a little bit. I'll come back in another 5 minutes. So back yet again. So it's been another 5 minutes. So we've been at 13 minutes total since I initially installed Ubuntu. Let's see if this works. There we go. Now we can actually install Apache 2. So I just wanted to show you, and I want to show you this in like real time to show you how a little bit frustrating it can be. So if you get a little frustrated, that's okay. So basically, when you initially log in the first time, you're going to change your password. If it's connected to the network, it's automatically going to start downloading those updates, and basically you have to wait for those updates to finish before you can really do anything else. It's just a pain in the butt. So expect, I don't know, it's been 13 minutes total. I'm not sure when it actually stops. So expect somewhere between about 10 to 15 minutes, right? From here, though, you can see that I am installing Apache 2. Going through, it's doing all of the installation, and I will just show you that you can then have a full Apache web server on Ubuntu once you've installed Ubuntu onto your Raspberry Pi. And again, this can be useful. You may be sitting there going, well, I can install Apache onto Raspberry Pi OS. Why would I want to install it onto Ubuntu? And again, it's the whole concept of standardization. If all of your machines are running the same distribution, they're running more or less the same version. Obviously, you're going to have different versions in a production environment. You're going to have newer and older machines. But if everything is basically running the same distribution, then when somebody sits down, they know what to do. So I can do, let's see here, IP address. So I can pull up what the IP address is here. If I take a look, I can see it's 192.168.1.23. And so I can then go over to my demonstration machine. Since this is on the network, I can open up Safari. I can do 192.168.1.23. Yeah, .23. And there we go. So this is the actual Apache 2 Ubuntu default page, and this is on the Raspberry Pi. So this here, again, this is on my MacBook Pro, and I'm able to access the web server, the website that's now being hosted on the Raspberry Pi using Ubuntu. So that's how you're able to install Ubuntu onto a Raspberry Pi. It's a very simple process with, it's the technical world. So there's a few frustrating things, because there's got to be frustrating things, but overall it's surprisingly simple to do. So there you go. Now you know how to install Ubuntu onto your Raspberry Pi. There's not really a whole lot to it. Not much you can screw up unless you don't let that update process go through. So I will tell you, when I was first doing this, I had the update process going through. I was a little frustrated. I was a geek. I didn't want to deal with all this. So the first thing that I did was I plugged in the reboot command. I just wanted to reboot, try to cancel out of the process. When I went to reboot, it said, warning, you have a process that's already going on. You have to wait to let this process finish. I was said, you're going to tell me what to do? No Raspberry Pi is going to tell this geek what to do. So I just yanked the power supply and plugged it back in to try to reboot, and corrupted the operating system. It's kind of hard to screw this up. But if you pull the power while it's doing its updates, you might corrupt the operating system. So what I would say is, again, when you install the Ubuntu Server OS, when you boot everything up after you change your password, just go grab a cup of coffee or go get some lunch. Let it go through the update process. If you try to stop it, bad things can ensue. So really, that's the only major way you can screw anything up. Beyond that, again, it's really nice because the images for the server and for the IoT core are built into the Pi imaging software. So just like you would install the Raspberry Pi OS, you can install Ubuntu Server or Ubuntu IoT core. The one thing that I will warn you is with the IoT core, again, that's kind of a different distribution. It's a different tweaking of Ubuntu. So no snark against IoT core. It's actually a very good distro, but there are differences. So if you're expecting server and you install IoT core, it's going to be a different environment, and hey, you're gonna have to do some Google searching to figure out what the hell's going on. So be careful with that. So I really think this is a pretty cool thing, though, because again, 99.9% of the things you would do with a normal x86 Ubuntu server should work on the ARM on the Raspberry Pi, and so this is a way you can create very small servers to provide services for your particular environment. So you could have a Samba server, so a file server. So you could have a dedicated Raspberry Pi file Samba server. You could have a dedicated proxy, like a Squid proxy server. So Squid proxy server allows you to do things like caching. So when people go out to the internet, they download files. When the next person goes out to download the exact same file off the internet, it can actually be cached on that proxy server and can be pulled locally instead of having to be brought off the internet. VPN servers, that type of thing. I actually think using the little Raspberry Pis might be a very interesting way to create infrastructure for your environment and also have it be relatively secure. So back in the old days, one of the problems we had is that each physical server would provide a lot of services for the network. And do remember, every feature, every function a server has is also a vulnerability, right? So if you have like one of the old Windows small business servers, so if you have a small business server that basically is your Active Directory server, and it's your email server, and it's your file server, and it's your VPN server, and it's your SharePoint server, and it's probably doing a couple of other services, right? All of those different services are a vulnerability. So if somebody can basically get into your file share and manipulate something, literally by going in through the file share, they may be able to manipulate something that gets them into the Active Directory, right? That's a vulnerability. So one of the things that we started doing is in the virtualized world, the idea is each virtual machine now provides those services. So you have one virtual machine or one virtual server, and that is now your file server, and that's all it does. And then you have one Active Directory server, that's all it does. You have one SharePoint server, that's all it does. Again, it's a more secure environment because now each virtual machine is only providing one service, but there is still a vulnerability because they are still within that virtualized world. You still have the hypervisor that's running everything. You have single points of failure. So if your hypervisor server fails, then everything above that, all the instances will also fail. So something to think about with your environment is this is a way for a relatively low cost, you can have dedicated servers. So if you look at the Raspberry Pi 4, you can get up to 8 gigs of RAM on one of these things. It's a quad-core processor. You shove in a micro SD card. So somewhere $100 or less, you could have a physical server. So you have one physical server that's your file server. You have one physical server that's your proxy server. You have one physical server that's your VPN server. You have one physical server that's your whatever else. And this way, you have no single point of failure. If the motherboard of your VPN server fails, it's not going to affect the proxy. It's not going to affect the file server. Again, and from a vulnerability, from like a hacker standpoint, if somebody's able to compromise your VPN server, I hope that doesn't happen, but if they do, they're not necessarily going to be compromising your file server, your proxy server, or anything else. So I think this is kind of an interesting thing to be thinking about in the modern world. And this is what you have to be thinking about as a technology professional. As new technology comes out, how do you design your environment for the new world, right? 20 years ago, everything was sitting on one machine because that's how we did things. Then everything started going over to virtualization. So you have instances of machines, but still in one or two basically very expensive boxes. Now it's kind of interesting to be thinking about. The cost of hardware just drops so massively. Can we kind of have a virtualized mentality, but actually do it in a physical world? So each one of these Raspberry Pis is now its own individual server, which means it's now siloed from a hacking standpoint from the other servers that you have on the network. And you don't have the single point of failure. Kind of some of the stuff that you should be thinking about. So anyways, as always, I enjoy teaching this class. I look forward to seeing you at the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.